There we go, that unmute button. Thanks, Jeff. I really appreciate it, and thanks for having me. I'll definitely get started with some background in a second. Just to set the context, again, thanks for having me. I've been watching some of these presentations throughout the day when I've had time, and it's been really inspiring to see some of the discussions, and it's just been very informative and great stuff to watch. So I hope I can kind of keep that tradition going, and as Jeff said, we'll dig in a little bit to some of the applied stuff, the ways that I apply data science, and my team and others at the Red Cross apply data science on a day-to-day basis. But first, like Jeff said, let's get into the existential question: who am I? And then we'll talk a little bit about the Red Cross in general, provide a little bit of context that will be helpful, I think. And then we'll talk about the current state of data science at the Red Cross. And then if there's time, we'll talk a little bit about the future state of data science at the Red Cross. So as Jeff mentioned, Brian Shepard, Director of Enterprise Data and Analytics, the data sciences group there at the Red Cross. We're one of a couple of different groups doing data science at the Red Cross. We are the enterprise level data science group. So what that means is, whereas some of the other groups are focused on a line of business, for example, marketing, our charge is to sort of collaborate and build a system that works across the enterprise. So enterprise AI initiatives, such as governance, or some of the things that we hope will take shape or will affect the entire Red Cross, rather than just a line of business. Those are the things that are sort of coming from my group. We are a new group, given that charge, despite that lofty mission. We are a new group. We started about 2.5 years ago, and that was when I first came to the Red Cross. And so what you'll hear I'll dig into this a little bit more as I get deeper into the presentation. But there is a lot of the history of the Red Cross, just mostly by the nature of the history of the cross and how it developed. There's still a lot of silos in terms of work and data. And so one of the things, as the newness of this enterprise level group should suggest, one of the big things that we are really working on is bringing those groups together and getting them to collaborate, whereas they historically have not. So there's been a lot of siloed data science happening over here. And of course, you can anticipate some of the challenges with that, with the redundant work and really not being able to get a big picture view of what's going on in terms of data science at the organization. So personally, I've been doing data science for about 20 years, or what you would now call data science, for about 20 years. Started off doing predictive analytics for in the institutional research group at my undergraduate institution, and have just kept with it since then, and have bounced around through lots of different industries. So another theme you'll hear from this talk today, hopefully, is that even though the Red Cross is a very unique mission, as we'll talk about in a minute, we're technically the only group in the country doing the type of work that we do. We still, a lot of the data science that we do is very generalizable. It's stuff that you might see at Walmart, it's stuff that you might see at Amazon, it's stuff that you might see at some other nonprofits that you're familiar with. So we'll come back to that in a minute, but that's something that I'm kind of hoping that you'll take from this presentation. I have a PhD in sociology from UT Austin. That's another, orange-based school. I hope you guys aren't going to hold it against me. But I've been glad to hear in some of the other presentations I've watched that there's a good bit of social science representation there. It's, early on in data science, there weren't data science programs. And so you really, to get into the field, you sort of had to have a background in a quantitative discipline like sociology. I've got a stats background there, or economics or something along those lines. So I'm glad to see that in recent years that there have been departments standing up to focus specifically on data science. I think it's really going to improve the quality of people in the workforce. So that's great. So again, now I want to talk for just a few minutes about the American Red Cross and the Red Cross in general, because you've probably heard about the Red Cross ever since you were born. I certainly had. But that term Red Cross gets thrown around in a lot of different ways, and there are some very specific organizations that that are good to keep in mind as we're talking about this. So the International Committee of the Red Cross was really the original Red Cross organization. They were founded in 1863, and their mission is really to assist those that are impacted by armed conflict, refugees, people in war zones, those sort of things. Another international group is the International Federation of Red Cross and Red Crescent Societies, and they were founded a little bit later, but their focus is on peacetime activities like international disaster relief. So you can think of a weather event that affects a lot of countries. The IFRC might be involved with that. Now, moving away from the international level, there are 192 national societies, and so you can infer what this means. This is groups that focus on individual countries at a time, and they have it's designed so that there can be only one official charter for a national society within a country. And so where I work and what I represent is the American Cross National Society. So it's good to keep that in mind. Our mission at the American Red Cross is different than what you might hear of for international relief efforts. We are focused obviously on the US, and fortunately we don't have a lot of issues with armed conflict within our borders. And so that's something that we focus on slightly different things than some of the international organizations you've heard of. All in all, it's to alleviate human suffering. If you look at the mission statements, that's the terminology used. But the shape that takes is different based on which organization you're working with and the needs of the communities that you're serving. So that's where we are. We're talking specifically about the American Red Cross. And so it's useful for you to know, as we talk about how data science is applied, the major lines of business at the Red Cross. And so there are lots of things that here, obviously. But when I think about, where can data science have the most impact, or, what are the core pieces of our business? There's really four things that come to mind. And I've got them listed here. And so we'll go through them for just a minute to, again, sort of give you the broad context of the scope and space of data science here. So the biomedical wing is if you've donated blood or if you've received a transfusion or something because of a medical procedure, this is the wing of the Red Cross that you're interacting with there. So this is, coming in to donate at a donation center. And then what you usually don't see that happens in the middle is that blood gets taken and turned into what we call a blood product. And there's a manufacturing process. A lot of these terms are going to sound familiar, right? But there's a manufacturing process for that that gets it ready for use in a surgery, or gets it ready for use at a cancer treatment center. And so that happens on the back end. And then once that product is produced, it's distributed to hospitals and medical centers for use, right? So that's the biomedical wing. Now, when you think of disaster relief services and, a hurricane hits the coast and you see all the volunteers out there and the initial responders out there, that's the humanitarian services wing. So that's disaster relief and response and also disaster preparedness. Then you've got the training services wing. If you've taken a first aid course through the Red Cross or CPR training, or if you've taken one of those courses from someone that was certified by the Red Cross to teach them, then you're touching there the training services group. And then there's the fundraising wing, which I'm sure we're all familiar with. Maybe you've gotten a call or 10 from the Red Cross, or you've seen, you've got some emails from us. But this is the fundraising wing. And fundraising is an interesting case for the Red Cross. It's not too much of a crazy thing for there to be a lot of variability in fundraising for groups. But with the Red Cross, the spikes and the troughs are really huge. We've got what we call blue sky and gray sky fundraising. And so blue sky is sort of just our natural sort of base level fundraising that we need to do to keep the lights on during the year. And then there's gray sky fundraising, which happens, when there's a weather event, a forest fire, something along those lines, some sort of disaster event. We have to be able to, obviously people then get energized to make donations. And so we have to be able to handle the scope and scale at both of those levels, sort of just the normal day-to-day intake, and then the huge peaks that come in around those disaster events. And so it can create some interesting challenges for forecasting, for one, to kind of bring it back to the data science scope. And then, of course, we do fundraising in different ways. We do online and offline fundraising. So it just adds another dimension to that. But these, again, tons of things go on at the Red Cross. These are the four main areas of focus, and really the when you think about topically what data science might do, the things that we would address. So let's talk for a minute about the current state of data science at the Red Cross. And so to do that, I really need to tell you about the data at the Red Cross. So prior to the 2000s, every Red Cross chapter, and you can think of a chapter as, essentially a building or a collection of buildings in a geographic space. It doesn't necessarily map out to counties, but it might be useful heuristic to think of it as, sort of county or MSA based, maybe metropolitan statistical area based, something along those lines. But the idea is a chapter was, a smaller fixed geographic space that had one or two representative functions happening in it, led by the Red Cross. The point that I'm trying to get to, though, is that each one of those chapters had its own set of data. It had its own email servers. It had its own storage servers for, information, digital information. It had its own systems that tracked the donors. And so you can imagine that this was almost impossible to analyze at an aggregate scale, and will make data science almost impossible to do at an aggregate scale. And so, unfortunately, around the 2000s, that we made an effort to start centralizing that data and putting it into places where it could be, sort of central repositories that could be accessed. With that said, though, the data is there's still large chunks of it that are very siloed. And the work that the groups that do the work also are still very siloed. So that provides, presents some interesting challenges for data science work there too. So like I said, though, we have made some strides in the right direction, and much, but not all, of the business data now flows to the enterprise data warehouse. Now, what this is that central repository for the data. And this is going to be the key business data. So the most important pieces that we need to do reporting off of, or, in our case, to do analytics for. This data gets set up in the enterprise data warehouse. And when it's there, once it gets to the enterprise data warehouse, that's a good thing for analytics. That means it's generally standardized. You can pretty much assume that it is either the ground truth data or very close to the ground truth data, which sometimes is okay enough. But anyway, so once it gets to the enterprise data warehouse, that's generally a good thing for reporting and analytics. So what that means for our data science inputs is that generally, just thinking about any random model that you might pull off the shelf, about 70% of our models are using data from the enterprise data warehouse. And then another 20% of that data comes from some other internal source, like some system that's not connected to the data warehouse. And maybe you have to do some sort of flat file download, like of a CSV or something like that, to bring it into your reporting or analytics. And then another 10% of that is the external stuff that exists outside of the Red Cross. So you can think of weather data, for example, or census data, things that aren't things that we would really have a need to keep, but we are additional color to the models. And so the image at the bottom is just kind of to convey the complexity of this even more. So like I said, I've been doing this for about 20 years. I've worked in a lot of different industries, and the Red Cross has the most complex data ecosystem that I've seen and worked with. We have data that comes from laptops and iPads in the field. We have people working on and producing things on desktops at their home office. We've got sensor data from the devices that actually collect blood, and then that information has to be uploaded to central places and then moved over to the EDW. So it's very complex. Data is everywhere, and that's part of why getting it to the EDW is important for us. So that's what the data looks like. What does the division of labor and what does the work in terms of like who's doing it look like? What's the data science ecosystem at the Red Cross? There are three primary data science groups. They are the innovation team, the marketing optimization and data science teams we call mods affectionately. And then there's the enterprise data and analytics data science group. That's me in my group. So The innovation team, as the name suggests, is this is the group that is working on, you can think of them as a high risk, high reward projects. So these are things that don't necessarily have a standard flow. They may be using a much higher percentage of new novel data that doesn't exist in the EDW than my group might be doing. But again, the thing to really take from that is they're generally the high risk, high reward, non-standard approaches. And we'll come back to that in a minute. Then you've got the marketing, optimization, and data science team. So marketing is, we'll talk about this in a second too, but marketing is a huge function for every organization that I've worked with and almost any organization you can think of. So there's a standalone group that focuses on that. That was one of the first data science groups to spin up at the Red Cross. And so it's one of the key groups that we work with today. And then, like I said, there's my group working at the enterprise level, trying to bring all of the data science functions together, trying to make sure that we're moving up levels of data science maturity, and really just getting things integrated, getting data science, promoting data science at the Red Cross, while also building any of the other models that don't fit into either marketing or innovation. And so what we really focus on is sort of, I call it the bread and butter models. So these are things that, but because of the way that data science, because of the way that data has evolved at the Red Cross, we haven't had centralized access to it. We've been collecting a lot of it, but haven't had centralized access to a lot of it. It's really, there's a lot of low-hanging fruit out there. There's a lot of, look, if we can just take a look at this and spend a little bit of time, we can sort of take an 80-20 approach. We can provide some marginal but useful incremental value without spending a year and a half developing this amazing, brilliant new thing that only gets us another 10% predictive value. So there's a lot of low-hanging fruit. There's a lot of bread and butter analyses that are going to bring value quickly, and that's really kind of what my group focuses on. And if I get to, if I have time for the slides at the end, we'll talk a little bit about what that looks like and how we're doing that. With all of that said, though, those three groups, we only serve probably, this is a gut number. I don't have any specific stats for this, but 10 to 15% of the business users at the Red Cross. The Red Cross is very report heavy right now. And so one of the challenges for my team, the enterprise team, is to really get data science, promote data science, get it out there, and get the stuff that we're doing just interwoven into the fabric of the Red Cross, and get people thinking about data science at the beginning and throughout the process, rather than thinking of it as just an extra layer that goes on top of whatever's done once it's done, right? So again, I want to kind of come back to this theme that even though the Red Cross has a very unique mission, data science at the Red Cross is going to look and feel very similar. So this may be something you've seen already, maybe not, but this is this is very similar to the CRISP DM model for the data science model development lifecycle. So this is sort of a standard set of steps that you're going to follow when you're creating a data science model. And I just put this slide here to underscore this is what we do. This is even at the Red Cross, this is sort of the same model that we're following, given a very unique mission. And I've noted here that even to the extent that 2 and 3 are the areas where you're always going to spend most of the time when doing your work is data prep and data understanding. But also I'll get on a soapbox here for just a second and say that number 1 is the part that's most important, that gets the least emphasis. Always, as you go forth into data science, remember the value of the business understanding and discussing the business users' needs first and foremost, so that the work that you're creating is useful. So let's hang out on this slide for just a few minutes. This is really, I want to dig into the use cases here and kind of give you, again, I'm going to kind of stick with this theme that it's very similar to anything else you might do, but this maybe will help give you a little bit of inspiration in thinking about things that data science can do that maybe you didn't think of or haven't thought of initially. But let's just kind of step through this, and I'll tell you some of the things that Some of these are going to be things that we're working on right now or have done already. And then some of them are going to be things that we have in our backlog that we plan to work on. But the types of models and the types of research that we do, I think really fall into 5 buckets: marketing, and then insight, forecasting, optimization, and natural language processing. So we started on the left and just hit some of the emblematic or typical types of marketing research that are either being done or could be done at the Red Cross. And the first one is churn likelihood prediction. I'm going to tell you, this is something that everywhere I have worked has done a churn model. So this is something, there's probably a 90% likelihood that if you go into applied data science, you will build a churn model, or there will be a churn model there. So what churn is, if you're not familiar with that term, is, retailers, it's easy to think about this in the retailer context. So let's say that you go to Target and you shop every week, and they know that you're a loyal customer because you come every week. Well, if you start to drop off and only come every 2 weeks or every 3 weeks, or maybe just don't even come at all, that's considered churn from their perspective. You were once a loyal customer that engaged with the products or services, and now you've gone away. So that's churn. And organizations and businesses want to know about this, because if they can identify it before it happens, before you're completely gone, then there might be something they can do to intervene and change your mind, right? Or if you have already churned, and that might be a different type of messaging. They say, hey, we miss you, come on back, or something like that, right? But even if there's not an intervention that can be done, this can be taken into account for forecasting, or it can be used for determining your ultimate customer lifetime value. So it's good to be able to say, all right, we can expect 10% churn this month, and take that into your budgeting and forecasting. So again, very common marketing model. Something else that is very common is wanting to identify the best channel prediction. The best messaging channel. So should I reach out to you through phone? Should I reach out through snail mail? Should I use some other method? What is the most likely channel through which you're going to respond to my message? And then there's customer segmentation, which is, again, a very common marketing approach. This is, you can think of it like a data reduction technique. You've got 1 million people, and you want to break those 1 million people down into 5 distinct groups that are very similar within the group, but very different when compared to the other groups. And the idea is that if you can do that, then you can maybe reduce your number of messages to 5 that are mostly effective, versus trying to personalize individually for every one of those 1 million people. So again, marketing, just like lots of organizations, is done at the Red Cross. We want to reach out to people and have them come in and donate, and we want to have them either donate blood or donate time or donate funds, because that's how we are able to provide the services that we provide. So moving to the right here, this insight bucket is really insight into why things happen and what's going to happen, right? So you might think of the case where drivers of disaster severity would be useful to know. And I can tell you right now, this isn't necessarily something that we're looking into, but is something that is on the backlog. It would be great to know what really impacts the severity of a disaster. Is it wind speed? Is it storm surge? Is it preparedness beforehand? And the obvious benefits of that are you can, whatever that driver is, if it's something like preparedness beforehand, or some specific component of preparedness, maybe messages about having your go bag ready or something like that, right? Then you can hopefully move those levers. Now, obviously, you can't really affect wind speed or storm surge or anything along those lines, but you can, maybe build things in a certain way that will help mitigate those. And sort of along those same lines, one of the models that we're working on now is helps predict the risk of the likelihood of a home fire in given geographic areas, right? And so one of the main things that the Red Cross does is what's called our home fires program. And one of the main types of disasters that we respond to is house fires. And so if we can, build a model that says, all right, this is really where we want to focus. There's a high risk of fire here, and the fires tend to be severe. Then that really helps us focus our efforts in, as part of our home fires programs. Another interesting one that we're working on is when you come in to donate, you go through a process of, you fill out a survey when you come in to donate blood, sorry. You fill out a survey and answer some questions. Eventually you'll get your finger pricked to see what your iron level is. So at several steps within that process, you can get what's called deferred. And that means we'll say, hey, today's not a good day for you to donate for whatever reason. Can you maybe come back in 3 weeks or something like that? And so obviously that's less than ideal from the donor perspective. So if there's something that we can do to build a model to predict that likelihood of deferral beforehand, then we can send a message to that person and say, hey, it looks like if you come in now, you're going to have this less than ideal experience. Why don't you wait a couple more weeks to come in or something like that? Or when we're scheduling the appointment originally, we can take that into account. So like I said, those are the kind of things that go into the whys or the what's going to happen. And then moving over to the right one more, we get into basic supply and demand forecasting, right? And the way this looks at the Red Cross is we have the blood donation supply coming in from the donors, obviously, and then we have the demand coming from the medical centers. And so the better that we can forecast those and get them lined up, the better we're going to be able to provide services. Financial donations, this is, again, an obvious, and like I mentioned early in the presentation, the better that we can plan for those troughs and peaks, and the better that we can sort of have a good idea of what the finances are going to look like 2 or 3 years down the road, the better and more effective and more efficient we can be. So, and then at the drive level, at the blood drive level, so a lot of our sites are what we call fixed sites. And these are the ones where there's a building there and it's got the Red Cross logo on it, and you go in and it's always there, and it's always, it's like a 9 to 5 operation, right? But of course, there are also blood drives that are mobile drives. They may be in a bus, or they may be in a church or a high school. And so we need to be able to forecast how many people are going to be interested in donating so that we can have the right labor, the right number of people there to do it, the right number of products, the right number of blood bags to collect things in, and that sort of stuff. So there's a drive level forecasting that's useful too. So, and then there's just moving one more to the right, general optimization tasks. When you come into, and you can think of these as slightly different than linear models. These might be the types of things that you would use reinforcement learning for, something along those lines. So these are less predicting a probability or predicting a number or something like that, but more optimizing the flow of a process, like Google Maps does when you say, I want to go here and get here. I want to start here and go here. It's more along those lines. So when a donor walks through the door, there are several steps that they go through and several stations that they go through. So you can go into station 1 and then be asked to wait to go into station 2, and along those lines. So it'd be great, it'd be a good user experience if we can optimize that as much as possible. So there's the least wait time, but there's still efficient use of our resources, like especially the phlebotomists that are going to be there taking the blood. And product deliveries and routes, while all of our products do have a certain shelf life, and so it's generally measured in days. And so the more optimal our routes are, the longer that shelf life is usable, right? If it takes us 10 days to get a product out, then that shortens the life of that product by effectively 10 days, right? So if we can make that more efficient, then we can keep that product around longer and make it more useful before we have to get rid of it. And then there's business processes and methods. And this is one of the things that we're really looking at now. My group is really looking at now. So in our IT department, for example, there's huge collection of code bases for getting things into the EDW and just any type of systems design that you can think of. And so one of the challenges that we're working with is, as we're making a lot of transformation in our IT department, which is also happening, I won't go into that too much, but there's a lot of changes going on in our IT area too, just lay that context. But as those changes are happening, how do we prioritize, there we go. How do we prioritize where testing happens, for example. So one of the things that we can do with our data science models is predict where things are most likely to fail. And so that's a good place to target testing and to reduce technical debt, which are, coding terms I don't want to get into too deeply. But the idea here is that these are operational processes that we can look at and apply data science to, versus a lot of the customer-oriented applications that you would see at Amazon or something along those lines, right? All right, and then finally, to wrap it out, this last block over here, the natural language processing, we do have some survey analysis and survey research that we do, and we have used some NLP approaches to dig into the open-ended questions there. And then Red Cross has a Twitter account, and there are various ways that we get feedback from areas like that. And so a pretty common approach these days is to have some sentiment analysis done on those methods of feedback. And then one of the cooler things that the innovation team has worked on recently, they've been doing some work with virtual reality apps. I don't know that they've done a lot of data science work with that, but I think the plan is that they will integrate some models into that. But they have built some models to help with smart speaker apps like Alexa and Google. And I apologize if I set off anyone's devices that's calling in from home. But yeah, some of that cool, interesting application type stuff. And then another one that I don't have listed here, but is sort of like a canonical example of something that we might do in the innovation space that is on the backlog. It hasn't done yet, but we have the ability to send out drones to take pictures of disaster spaces, and it would be really great if we could use some cool image recognition or some image classification to use that to identify the severity of a disaster, right? Or maybe to classify certain things about the disaster from just the images, because as you can imagine, maybe with forest fires or something along those lines, or just very remote areas, there are definitely places that are difficult for humans to get to that a drone can get to easily. So I'm just got one or two slides. I'll go ahead and finish this one out, and I think we'll still have time for questions. Where is data science at the Red Cross going? Like I mentioned, in my group, one of the main things that we're working on is increasing AI maturity. There's been the groups, the innovation team and the mods team in my group. There hasn't been a lot of collaboration, just because, again, there wasn't there was so much side application in terms of the way the groups interacted. So one thing that our group my team is really working on is bringing those other groups that are doing data science, not just those other two, but there are other individuals and small patches of data science happening across the Red Cross, really getting everyone connected and working towards the same direction and talking to each other, so that we're not duplicating efforts, and so that we're making the best use that we can of all of the resources, artifacts that people are creating. If you're familiar with the term MLOps, this is machine learning operations, which is kind of a evolution of an IT term called DevOps, which is really just standardization and automation of a lot of processes. And it's making its way into applied data science these days. If you think of the things that differentiated some of the large groups, some of the large companies like Amazon, Netflix, Google, why they were successful, MLOps, although it wasn't necessarily called this then, is what it boils down to a lot. This ability to standardize a lot of the model development process and do what I call factory data science, just widget models, right? Start to end, very quickly, and really integrate, and by doing so, integrate that into the fabric of their organizations. And again, that's what I've got here at the bottom. Just making data science part of our DNA, part of what we do. And then the last thing I'll mention real quick is this idea of enterprise AI governance, which feeds into that idea of connecting and surfacing all of the AI that's already going on at the Red Cross, so that you can be more efficient going forward. This is essentially governance. In this case, means cataloging what's happening and where things are in design and production, so that it's discoverable. You can search it and say what's going on in the blood donation space in terms of models, and then also so that you can so that it's transparent and auditable, and then so this also feeds into things like responsible AI, because that we want to be able to provide the lineage of the data. We want to be able to say that we've looked at certain things and checked for bias, that models meet bias standards, and those sort of things. So that is the last thing that I have, except I do want to say, I like to take these opportunities to say thank you. I know that there are going to be some blood donors out there, and there are going to be some financial donors out there, and there are going to be some people that have donated their time. And so I just want to say a huge thank you. My job wouldn't exist without you, but more importantly, all of the services that we provide wouldn't exist without you. So just a quick thank you for that. And I will go ahead and put my contact information up while we answer questions. I love people reaching out to me. I have worked in academics myself and love teaching. I teach a couple of courses in data science every once in a while. And so I love that interaction, and am very welcome to share my experiences and knowledge anytime anybody wants to listen. So thank you.
Thank you. I think we still have time for some questions. So both as online folks as well as folks in the room. While you're thinking, I'm going to start the first question off, which is, obviously a lot of people in the room and online are thinking about getting a job. So what would be maybe the one or two important skills that you would look for in somebody in your team that you're trying to hire?
Yeah, it's a great question. So I'm going to get, very vague and very specific. So one thing is obviously the critical thinking piece and the research methodology side of it. As I mentioned a little bit before, the idea of being able to connect with the business user and really dig into what they need, right? A lot of times there's a hype cycle for data science and AI, and we're still in the deep throes of it. And so, people will hear about some new model, or they will hear about data science in general, and they'll come and say, I want this model. And that's really not what they need. So the ability to just sit down and talk with them and ask questions and really get to what the business need is, and even more specifically, if you can, sort of the key performance indicator, the metrics that they will be judging success by. And then you, as a data scientist, can go back and figure out what the right model is. And that's almost always, and this is why my group focuses on the bread and butter stuff, because it's almost always a simple solution. And it's not something we want to overthink. So just that critical thinking ability, the communication ability, to dig in with a business user, figure out, how to meet their business goals with your data science tool set. But that's really a communication skill, I think. And then the other very specific thing that I would say is SQL expertise. This is something that, at least in my experience, isn't often taught in a formal setting, but is very useful in applied settings. And this is going to vary a little bit by where you end up. But I have used it in most of the organizations that I've worked with, especially if you're going to a research institution, then it may be less important because your data is probably going to be cleaned up and nice and pretty already. But if you're going to a retail organization, or if you're going to an area where things move faster, then it's a very good skill to have. And like I said, not one that is often taught, but I use quite a bit.
Thank you. Any questions here? Before we move on to the next one, I want to remind everybody that you become an expert in SQL and SQL through the required courses 659 or 359. So
great. That's awesome.
Question? All right, right, thank you, Brian, thank you very much, I appreciate you taking the time.
Thanks so much for having me. Bye.